Hello and welcome to the AHR Expo 2025. I'm Matt Wood and with me is John Withouse. And we're going to
Hi,
do
Matt.
a webinar today. Hi, John. Webinar today on refrigerant regulations in supermarkets, but I'm not the expert. John will be doing most of the talking. My name is Matt Wood. I've been with Sporlan for around 13 years. I'm currently our applications engineering manager.
Hi, Matt. My name is John Withouse. I've been with Sporlan almost 17 years now, and I'm the senior principal engineer for the division.
Excellent. We're going to get just right into this with sort of a question and answer interview type style here.
Mhm.
And the first topic is going to be, EPA and what refrigerant regulations are most affecting supermarkets in 2025 and beyond.
Okay. So there are regulations that are administered nationwide via the EPA. That includes the AIM Act, which we've heard a lot about over the last few years. Also, SNAP, that's approval of new refrigerants. The AIM Act includes a production and consumption phase down, includes technology transitions, which sound new, but they're kind of actually familiar to some things that we've been seeing under SNAP in the past. There's also refrigerant management practices under the AIM Act. And then you also have some activities at the state level, particularly in California and New York State.
And just for some of us that aren't living in this world, what does SNAP stand for?
Okay. SNAP in this case, actually there's several different acronyms for SNAP, but in this case it stands for Significant New Alternatives Program.
Okay.
And it was that was actually initiated by Clean Air Act Title VI way back in 1990.
Okay. Well, it's always good to know what we're talking about here. Those acronyms can get mighty wordy at times. Sorry, just had a little technical difficulty there. Next question. And why are we talking about SNAP? I thought a federal court sort of nullified a couple of SNAP rules and made them not really applicable.
They did. EPA initially wanted to use the SNAP program to start phasing out HFC refrigerants. There was a couple of SNAP rules that were issued, SNAP 20 and SNAP 21, that did that. And there was a court challenge to that. And that court challenge was successful and said that EPA, you don't have the authority under SNAP to regulate HFCs. Only things that have ozone depletion potential, which HFCs do not. And so that was actually decided back in I think initially 2017, and went through a couple of appeals. It was actually appealed to the U.S. Supreme Court. They declined to hear it, and so it became the law.
Wealth of knowledge. This is fascinating stuff. I'm glad there's someone like you to keep it straight in my head.
However, even though we don't have a HFC phase down under SNAP, SNAP is still the way new refrigerants are approved for use. And since we're talking about supermarkets here, the most relevant thing we can talk about with SNAP is SNAP Rule 26. SNAP Rule 26 was a rule that was finalized back, I believe it was middle of last year, that opens up 10 or so low GWP HFO and HFO blend refrigerants to use in supermarket type systems. And it includes things like use conditions. And, we've been able to use very small quantities of propane, R290, as a refrigerant in supermarket equipment for a while now. But it's been some very, very tight charge limits on like 150 grams. And this SNAP rule opens up the use of significantly larger charges of propane, 300 grams in open cases and 500 grams in closed cases.
That's a big deal. That's going to make a lot of difference in the use case.
Ultimately. It really does. Even that doesn't sound like much, but R290 is a very high volumetric capacity refrigerant. And with some smart system design, you can do a lot of refrigeration with just a half a kilogram or about 1.1 pounds of it.
Wow. And I'm sure if you think about natural gas heating and things like that, you've got a lot more R290 in your house than that already if you're.
Very much so. Very much so. It's a little different situation. That's a little bit different use case, but it's a very very true. And of course, the other thing was there were a lot of approvals in years past for the use of CO2. So CO2 has been basically SNAP approved for use in all kinds of different systems.
All right, let's move on to our next question. The AIM Act phases out the use of HFCs. Is that correct?
It does not phase out the use of HFCs. It phases them down.
Right.
So it's down to 15% of a baseline, but it does not phase them out completely. The baseline for the U.S. is calculated on the 2011 to 13 production and consumption of HFCs, plus 15% of the HCFCs that were used in those years. That's recognizing the fact there was still a significant amount of R22 usage back then. So currently we are at 60% of that baseline. That was as of the 1st of 2024, or basically 13 months ago. And the next step down is in 2029, the 1st of 2029. That's going to cut that in half to 30% of what we were at basically at 2019, 2020 timeframe. So it very much, it's a very large reduction, but it's not a complete phase out. A couple other things that are kind of important about that phase down is the fact that it's GWP weighted. So if you look at the HFCs, the way the regulations are written, it all comes down to CO2 equivalent, or really million metric ton CO2 equivalent in terms of the warming potential of these HFCs. So bottom line is the higher GWP HFCs like R125 and R143A, which are the two largest components of 404A and 507. We'll talk about some refrigerants we actually recognize the numbers of here. Those are the ones that are going to get restricted the most, the soonest, and they're going to be the most highly restricted refrigerants because less allowed.
Less allowed.
Less allowed.
R125.
Mm-hmm.
Ones we recognize.
Yep. And the other thing to point out is the AIM Act. We also have some HFOs out there now to choose from, have had for several years. And the AIM Act does not regulate HFOs. It only regulates 18 specific HFCs that are, excuse me, those constituents of the refrigerants that we're familiar with.
Okay, so the AIM Act doesn't regulate HFOs, correct?
No, it does not.
All right, we've been talking about the AIM Act, but you mentioned that it also includes technology transition plans.
Mm-hmm.
So what is that, and how would it affect our supermarket customers?
Okay. So under AIM, they use the term technology transitions, but really that's very much like the delisting that we saw under SNAP when we were getting rid of things like R22 and a lot of those other ODP type refrigerants. And it's mostly done by GWP limit. Not everything is done by GWP limit. A notable exception is commercial ice makers. They're still done kind of the way SNAP was, which is by having an allowed list of refrigerants and an unallowed list of refrigerants. Our GWP limits in supermarkets, essentially, you have two levels. You have 300 GWP for systems with a charge that is less than 200 pounds, and for the high side of cascades of any charge, and then 150 GWP limit for small self-contained systems and for large systems, so rack systems, things that would have a charge that's 200 pounds or greater. Some of those limits are already in effect. Some of those went in effect as of 1/1/2025, so they've been in effect for a little over a month now. That would include that 150 GWP limit for self-contained systems. Then in a a little less than a year, 1st of 2026. Condensing units, or what we might think of as conventional systems, those will be restricted. Most of those systems are under the 200-pound mark, so they're going to be, essentially that's when the 300 GWP limit's going to go into effect for them. And then finally, in 1/1/2027, rack systems will be subject to that 150 limit.
So it would be fair to say that this is on the way. This is what we're going to be dealing with for the next several years. these
Absolutely.
transitions.
Absolutely.
And we're talking about retrofits or new equipment or both?
This under EPA, it covers new equipment only. There's no retrofit coverage under EPA, although they're kind of getting to that by some other methods. However, it is important to note that some state regulations do cover retrofits.
The states like to do it their own way.
Some states have some regulations of their own, which we can talk about later if we have time.
All right. Well, let's pivot to refrigerant management. You mentioned that.
Yep.
And what does it look like for a supermarket under the AIM Act?
Okay, that's actually the newest part. That's the most recently released final rule under AIM. That dates back to just, I think, late October of 2024, so it's a relatively new regulation. It does look somewhat similar to the refrigerant management regs under Section 608 of the Clean Air Act. That was, of course, on ozone depleting substances. So you can draw some parallels there. One aspect of it is that everything is kind of pushing toward the use of, reclaimed HFCs. So reclaim those HFCs out of systems. You need to do that anyway. You can't vent them. That's illegal to vent them. But reclaim those and reuse them, However, to get an HFC blend back to spec, back to AHR I-700 standard specs, you cannot use more than 15% of a virgin HFC to bring it back there. So, and that's actually effective in about a year, the 1st of 2026. One of the aspects of the Section 608 rules were maximum annual leak rates. If you had an annual leak rate above a certain percentage, you had to repair the system. Well, now that's applied via the AIM Act, and that's for commercial refrigeration systems, supermarket systems. It's 20%. So if you're leaking more than 20% of the charge of the system in a year, you have to repair it by law.
Probably a good idea to do it anyway.
Good idea to do it anyway, because refrigerant is not cheap, and it's not going to get any cheaper.
Exactly.
Yeah. And then there's also some new requirements for automatic leak detection systems. If it's a new system, if it's over 1,500 pounds charge, which that sounds like a lot, but that's not actually that large of a rack system. That's a, kind of average size rack system. It has to be on, that's anything with a GWP over 53.
Okay.
It's kind of an odd number, but that's where they picked it. That's on new systems by the 1st of 2026. And here's where there is actually sort of a retrofit requirement, if you will. If any system that meets those same things, meets those same guidelines, 1,500 pounds, GWP 53, if it has been installed since 2017, so in essentially the last 10 years, if you want to look at it that way,
Yeah.
it has to have an automatic leak detection system installed on it by the 1st of 2027.
Oh man.
So you've got about 2 years, and if it was installed before 2017, you're kind of off the hook there. But if it's been since 2017, you still have to install an automatic leak detection system on it.
So you might have some retrofit there.
You might have some retrofit there. And then here's kind of a big one. Last but not least, as of the 1st of 2029, so a little less than 4 years from now, supermarket systems are going to have to be serviced with reclaimed refrigerant.
Reclaimed refrigerant.
Mm-hmm.
All service.
All service have to be done with reclaimed.
Oh man, that's going to really.
So that's going to be an interesting landscape then, and it's a really good reason to start reclaiming your refrigerant now and looking at that as a valuable resource
by 2029.
Yeah. So,
Going to be something different.
yeah. And, you're not going to want to let that stuff go into the air uh, because it has real value to it, and it's going to have greater real value by that point in time.
Right. So, next question is, what EPA regulating servicing of supermarket systems under AM, or with EPA regulating servicing of supermarket systems under the AIM Act? What does that mean for the availability of components, parts, services like what we sell and manufacture?
Yeah.
Thermostatic expansion valves, PRVs, the like.
So it was very interesting when there was a proposed rule that came out. We were looking at it and said, well, gee, this looks like it covers our products, and we're going to have to be really careful about, how we manufacture products, particularly thermostatic charges for TEVs and things like that. But when the final rule came out, it definitely addresses components. There is a definition in there of a specified component, which includes these 5 things: condensers, condensing units, compressors, evaporators, and evaporating units. And that's only those 5 things. Now, those things can still be produced basically for use with any refrigerant, but with those 5 things, they have to be labeled, and there has to be records kept on them, and there has to be reporting to EPA on those components. But other components, essentially like most of our products, actually are unregulated. And the reason they gave in there is, and they even actually recognized thermostatic expansion valves directly in that rule, is that they don't contain significant amount of HFCs. Significant amounts of HFCs. So
an insignificant amount is okay.
Apparently so.
Okay.
And it does recognize the need for components for continued servicing of systems. So, one of EPA's stated goals with these regs is not to strand or shut down existing systems. They don't want to force everybody to put in a new system based on these. And so they made it such that they can still service the systems by purchasing replacing components that we've built for decades.
All right. Well, I'm going to go ahead and hit on this question. It may be specific to certain states.
Okay.
But what are the state level, if any, regulations affecting supermarkets?
Okay. So most directly facing supermarkets, there is an organization called the U.S. Climate Alliance that was formed basically when that SNAP rule was struck down by the court. There's an alliance of states that said, oh, gee, we really need this rule in place. And so what several of those states did was to enact the provisions of SNAP rules 20 and 21 into their state laws. They did this in different ways, and it's a different landscape. We don't really have time to discuss all that here today, but that is out there in several states. But most notably, the 2 states that have, or you might even say 3 states that have had some significant regulations on their own that do some very different things from EPA would be California, and Washington State's kind of following California, and then New York State. To kind of summarize them, California set their own GWP limits. It's actually really similar to the Ames limits, though. So the Ames limits didn't turn out to be much different at all. But most interestingly, on supermarkets in California, they actually, and this is where I mentioned a while ago, existing, GWP limits on existing systems. Essentially, there's 2 steps to this, but essentially all supermarkets in California, if you're a chain that operates in California, can be an average across all your facilities. They must have an average GWP of less than 1,400 by 2030.
So average across different supermarket installations and types of equipment. So you could have
Correct.
a legacy system that you still have 5 years of use out of, and instead install a new CO2 system somewhere else to balance out. Okay.
Right. So if you've got some 404A stuff, you could install some CO2 and actually offset that. But there's still a but on that as well. So California also put GWP limits on new refrigerants for service. And as of the first of this year, the highest GWP new refrigerant you can purchase in California would be 2200. And so that you're out of luck on new 404A or new 507 in California.
And that's new, not
Not
service.
reclaimed, not reclaimed.
Reclaim must be used for service.
Yep.
Okay.
Yep. And that actually steps down to 1500 in 2030 and then 750 in 2033.
Wow.
So it steps on down from there. And then, of course, there's New York State. We really don't have time to actually discuss this in detail here, but I'll just say it's an extremely complex regulation. It covers just about every application you can possibly think of that might use a refrigerant in that state. Where it gets really complicated is, most people may not even realize this, there are different time horizons for GWP. All the GWPs that we talk about normally are 100-year time horizon. But the IPCC also publishes 50-year and 20-year time horizon GWPs. The entire world uses GWP 100, the entire world with the exception of New York State. They decided that they needed to use GWP 20. And there is no convenient cross-reference. The numbers changed radically between GWP 20 and GWP 100.
And is that because some of these gases have different lives and
Very much so.
impact that number on different time scales?
Yep, exactly.
So no real good way to compare. So
No.
when I'm in New York, I'll start thinking metric, or I should say GWP
Yeah,
100.
yeah. So they do have in some of the regulations, some of it is still based on GWP 100. That part of it kind of makes sense. And that part of it does not look that much different from California or AIM. But then you get out into the 2030 to 2034 time frames, and they have those restrictions that are then based on GWP 20. Essentially, one of the things it's done is, as of, well, gosh, I guess about a month ago, 1/9/2025, it banned all sales of R404A, R507, and R22 replacements in the state of New York.
Wow.
And of course, as you might imagine, there was kind of an uproar over that because of various entities, end users, wholesalers, manufacturers that might have had a significant stock of those refrigerants, maybe several $1 million worth of those refrigerants
I'm sure.
stock. And so to address that, they have actually put out a publication saying, well, we're not going to enforce that regulation now. Not we're going to change it or we're going to make this, somehow right long term. Well, for 6 months, we're not going to enforce it. So effectively, just go ahead and break the law and we'll look the other way.
But the law is still there.
The law is still there. Yeah.
Amazing.
Yeah. So it's wild.
Wild times in New York.
Yeah. Yeah.
So let's move on to our next question here.
Okay.
What are the refrigerant choices available for supermarkets with GWP limits between 150 and 300?
Okay. So, we talked about before, you have these kind of three silos that we can look at here. We have self-contained systems or standalone systems. We have systems with less than 200 pounds charge, and then you have those systems that are over 200 pounds charge. So for the self-contained, really a lot of those systems are moving very much toward propane, R290. With the new charge limits that are now available, both via SNAP 26 and UL 60335-2-89, the safety standard that you basically have to use now to certify those systems. Those are, those 300 gram and 500 gram limits are now available via both those documents. And so that's actually a really good choice. Propane's an excellent refrigerant.
If you're small enough, you can use propane.
Small enough, you can use propane. You can also, of course, use CO2. But, overall, the propane system is probably going to be easier to manufacture. And it's probably going to be more efficient.
Very important.
Yeah. Yeah. When we go to those systems that are, above the opposite end of the scale, the 200 pounds and greater charge limits, which also have that GWP 150 charge limit coming in on them. There actually are several A2L choices out there now. There's a few of those that are probably going to be medium temp only, like R1234YF and R1234CE. Those are pure HFO refrigerants. There's also a blend called R516A out there. That's sort of an R134A replacement that is sub 150 GWP. And then there's some others out there that can be low temp or medium temp, either one. Those would include things like R454C, R455A, and R457A. And those are going to, be applicable in a lot of cases. They're going to be fairly applicable in the same way that some of the current A1 choices are. So things like R448A and R449A that we've been using for the last, arguably almost 10 years now, they're going to be kind of similar in application to those. But as far as an A1 choice in those larger systems, there's really only CO2. That's about it. There's getting to be a lot of those transcritical booster systems out there. We're certainly, offering a lot more components for those types of systems these days. They can be a great choice, but there are some penalties there. First cost is typically a little higher on those systems, but they can be a very effective system nonetheless.
Absolutely. There's a lot of technologies, right, being used to drive that CO2 meridian a little further south.
Yep, absolutely.
Some additional technologies.
And then they're sort of stuck in the middle. You have those systems that are not self-contained, but are still under 200 pounds charge. Those have a little bit more leeway. They have GWP up to 300 available to them. It's kind of the same choices that we talked about for those systems over 200 pounds, right? R454A is also a choice there. It's over 150, but under 300 still. That can actually be a really good refrigerant.
Or low temp or medium temp?
Low temp or medium temp. Okay. Yep. That's actually a really good choice there. And then there's another A1 choice out there for those systems, R515B. It's sort of kind of R134A like. So if you could apply R134A to it, you could probably apply 515B to it. And that's also an A1. So you would avoid some of the additional safety, A2L safety items that you have to do by using 515B.
Wealth of knowledge here. Let's move on here. Next question is, with the new A2L blends, what's different about applying them in supermarket systems?
Well, really, as I kind of alluded to a minute ago, not as much as you might think. Pressures and volumetric capacities are, broadly similar to existing refrigerants. Component selection is generally similar, not radically different, and some of the same TEV thermostatic charge supply. There we have had to develop a couple of new ones. The 400 series blends like the 454A, C, 455A, 457A, they are high glide, but not that much higher, or maybe similar to 448 and 449. So those are some ones that we probably are already, familiar enough with. If we can apply those refrigerants effectively, we can probably apply these new ones effectively.
If you know how to deal with glide, then you'll know how to deal with glide in these new refrigerants.
Yep, they're not that much different. Like I said, maybe just slightly higher, but not that bad. That new safety standard that I talked about a while ago, the 60335-2-89, it is the one that NAF supports flammable refrigerants. We can't use those legacy UL standards to certify to anymore, unfortunately. It's the one that supports the higher charges for propane. When we start talking about the A2Ls, it's expressed as a multiple of lower flammability limits. And then we have some different charge levels in there. There's an M1, an M2, and an M3. It does go on the idea of releasable charge. So the system can be sectioned off with safety valves, safety shutoff valves. That allows a increase in the total system charge. And those are some of the valves that we have here at the show. We have the SSOV and the CSOV that are applicable in those type of applications. But for our components themselves, we're still certifying our components under updated versions of UL 207. And if it's an electric valve with an electric coil on it, like a solenoid valve, it would be UL 429. And so those are still the safety standards, the ones that we've been familiar with for a long time. Even though there are updates to them, those are still the ones that feed up to those higher level standards. So those are the ones that allow our components to be used in systems that are certified under the -2-89 standard. And if it's an AC type system, it would be 60335-2-40.
Air conditioning is 2-40.
Yep.
Refrigeration is 2-80.
That's correct. So
yeah.
AC and heat pump and things like that are under 2-40, and then refrigeration under 2-89.
Well, it sounds like we're already going there. But what Sporlan products are ready for use with A2L refrigerants? And you mentioned a little bit about the standards, but how did we get there? How was that accomplished?
A lot of work. Lots and lots of work. Sporlan Engineering, and then with a lot of help from our partners at UL, their certification engineers and staff, they've really helped out. That there was a lot of recertification that had to be done. As I said, those safety standards were updated with new requirements for flammable refrigerants. Essentially, all Sporlan products are compatible with A2L refrigerants. And that is talking in terms of material compatibility. We've done a lot of work with material compatibility over the past several years to make sure that these new HFOs work well with all of our sealed materials, but also design suitability and compatibility so that the products are actually engineered to work properly with. And that goes to things like thermostatic charge development, but also making sure that we have the right application data to effectively apply new refrigerants with our existing lines of product.
Sounds like a lot of work.
Absolutely. Also, we have our virtual engineer program, which is an online program that anybody can pull up basically through, the Parker.com website. It's basically an online application engineering program. And you can do your own product selection through that. All these refrigerants we've talked about here today, they're all fully supported in that program. Actually have been for a while. Should give a shout out to the Jason, our engineer that that does a lot of work with that program. He's done a great job of getting all those new refrigerants integrated into the program.
Yeah, I think a lot of our customers might know him by name just from getting such great support from him.
Absolutely.
And you bring up a good point that virtual engineer may be the quickest and most up-to-date way for our customers to get information about those new refrigerants and what's compatible and what products support different refrigerants.
Mm-hmm. Yep. And I'll just say this, there's been a lot of discussion about, the certification for A2Ls, and really right at this stage all of our major product lines are currently A2L certified. We have a couple that are basically in the very final stages of it. So under the UL 207, which is, most valves and contaminant control products, pretty much everything is either listed or recognized as it has been historically for A1 refrigerants. And then under UL 429, we have those solenoid valves, but also PRVs with solenoid operated features. So like, let's say an EPR, a Sorit EPR that is it's primarily an evaporator pressure regulator, but it has a suction stop, solenoid operated feature. Those are right now in the final stages of UL certification. So if you want to use Sorit with an A2L refrigerant, you're going to be able to do so just very shortly here. So things like that.
Excellent. And I guess lastly, I'd be remiss if I didn't talk about CO2 products. What's wrong with those?
So Basically Sporland's entire product line has been suitable for use with subcritical CO2 for a long time now. I mean, we're talking, probably a couple decades. You could use almost any of our almost any of our product line with subcritical CO2. We have a broad and growing line of transcritical CO2 components now. That would include things like the GC and FGB line, gas cooler and flash gas bypass line of valves. Now we also have the GCM valve, so that slightly smaller, lower capacity gas cooler valve. So getting down into the the CO2 heat pump range, it's great, be a great application for it. All these valves that we just talked about, those are all 140 bar rated valves, so they're fully capable on any transcritical CO2 system, fully capable. You also have the SER series of small electric expansion valves. Those can be a great choice in CO2. Most of those are now rated for 90 bar applications, so those are fully compatible with CO2 systems on the expansion side. We also have sealed model filter dryers ready to go for transcritical CO2. Also oil filters for CO2 rack systems, and we're continuing to work on other products as well. So things like a replaceable core CO2 filter dryer and we have some other valve things in the works as well.
And you had talked a lot about UL with our A2L products, but I would assume with these, we're talking the same thing. Approved?
Absolutely. Yep, absolutely. So we're getting as we get these, when they're ready for certification, we go ahead and get them certified. Typically, most of these are under UL 207. And there is actually some more, it is notable, there actually are some more stringent requirements for CO2 type products under UL 207. We have to pass some higher fatigue requirements on these and things like that. And, we basically haven't had one fail yet. So done really well with them.
That's excellent. And it sounds like when in doubt, our customers should check it out. We've got most of our products ready for A2Ls and CO2.
Mm-hmm.
And if they have a question, contact their local Sporland sales engineer to inquire. Right. I appreciate your time, John, and sharing your wealth of knowledge. I know my brain already feels like it's just expanded 10 times. Well, thank you everybody for joining us on this lunchtime podcast webinar episode. And we'll see you again at our next one, I believe, tomorrow.
Tomorrow, we're going to talk about data centers tomorrow. That's always an interesting topic.
Data centers.
Data center cooling.
The future and might say the present.
Yep.
All right. Thanks, John.
Yep. Thank you, Matt.